trying to hold Venn diagram relationships in your head might be the reason you keep getting lost. You see, high scorers, they all use one checklist, whether they're aware of it or not, right? And that's legend, overlaps, sketch and select, and totals. And today, I'm going to walk you through that method step by step. My name's Farhan, I'm a junior doctor, and I've helped over 100 students get into medicine and dentistry across Australia. And in this video, you are going to learn how to approach Venn diagrams with a clear system so that you can avoid wording traps and sketch or match the right diagram. So let's get into it. First of all, I want to start off with some principles for the Venn diagram. And there's only really one principle I want to go through, which is the word only. You see, it's a really important keyword for overlaps in Venn diagrams, because if we don't understand what the word only means and what it changes for the Venn diagrams that we draw, then we have the potential to get the entire Venn diagram wrong. So we need to understand how only changes the Venn diagram that we sketch. Let's run through a basic example. So, Marsha went to a dog show where she observed dogs competing for 3 types of ribbons: red, green, and blue. So, we know that there's going to be a red, green, and blue. Fantastic. Let's draw out these circles. This is what it looks like. Now, there were 4 dogs who won all 3 ribbons. Lovely. So, nothing tricky about that. We just pop a 4 in the middle because that's the intersection between red, green, and blue. There were 31 dogs who won red ribbons. Now, this is important. You see, the first mistake people make is that they put a 31 here, thinking that, well, if they won red ribbons, then there must be a 31. But the reason why this might be misguided is because this 31 in the stem refers to the entire circle that I've just now circled in both green and orange. So let's do the maths, right? 31 plus 4, that's already 35. That can't add up. So, had this said instead 31 dogs who won only red ribbons, then you'd be correct. But because it says 31 that won red overall, we can't really put any number in there so far because we don't know what this number is and we don't know what that number is. So, for the time being, what we're going to do is just put them on the outside so we know what numbers they are for both red, green, and blue, as in what number the total would be. Let's keep on going. In addition, 13 dogs won red and blue ribbons. Once again, that's referring to the intersection between red and blue, all of this, not just this section here. If it said only red and blue, then you're right, we're going to put 13 here. But because 13 refers to that section, we have to subtract this 4 from that, which actually makes that 9. And then so if we keep on going, 9 dogs won red and green, that makes that a 5. And then 12 dogs won blue and green, that makes that little intersection there an 8. Then we've got much more to work with. Let's keep going. Every dog at the show won a ribbon. So we know that there's a 0 on the outside. And now with this information, we can comfortably fill in the rest of the Venn diagram. The way we do that is, well, we know the total for red now, and we have all the other missing pieces. So if we subtract 5, subtract 4, subtract 9 from that total of 31, we're going to get the answer of 13. And we do the same for green, we do the same for blue. All of a sudden, we've got our complete Venn diagram. So this is how the word only changes so much about the way you fill out your Venn diagram. So let's answer the question now. How many dogs are there in total? Now you can add it all up. 80 dogs. So there we go. That's our example. Now, let's move on to the question types that you're going to expect to see when it comes to Venn diagrams in decision making. Now, I've categorized them into 4 different question types. This isn't official or anything. This is just the way that I've tried to make it simpler for you guys to understand. There's 2 types. They either give you the diagram or they don't. The ones that give you the diagram, there's 2 types within that: categories and which one fits. And for the ones that don't give you a diagram, there's a DIY one where you have to sketch your own, and then worded ones where there's no images whatsoever. So let's go into the method that you're going to use for all of these question types, which is the LOST method. This stands for legend, overlaps, select and sketch, and the total check. So let's go through step by step. Number 1 is the legend. This is where you orient yourself. You ask, what does each shape or circle or each region actually represent? What is this Venn diagram telling me? you also want to read the question and make sure you know what you're solving for. 2 is overlaps. This is where you want to understand where the intersections between the circles lie. You want to decode the words in the question like only, both, neither, at least, exactly. And you want to know exactly what these mean, but also what they look like in the Venn diagram. Next is selecting and sketching. So these are 2 different options based on the question type you have. If you are given a diagram, then you select the option that best matches the information. Whereas if you're not given a diagram, this is your cue to start sketching a Venn diagram to then represent the information. And lastly is the total check. You just got to make sure everything adds up. So if the question states a total of 46 people and you end up having 43 people, then you know that's not going to work out. And you also want to make sure that the answer option that you end up picking respects the conditions. For example, if it says at least one of the races gave out no medals, then you know that there's going to be one of those races that has a big fat 0 inside it because no one won that. All right. So now, it seems complicated because there's 4 different question types that you're going to come across. You've got this method, but really it's the same framework, just with slightly different applications to each question type. So let's run through that together. First of all is going to be the category section. These questions look like this, where you'll have numbers inside a Venn diagram, you'll have categories to interpret, and then they'll ask you a question, at least sometimes a direct question like this one, or sometimes one of those, which of the following is true. So how do you approach this using the lost method? First of all, comes legend. Before anything, you want to interpret. You want to interpret, number 1, the legend. You want to know what the shapes are actually telling you. Because if you don't interpret it then you'll end up needing to go back to interpret it at some point anyways. So just like a little quick 10-second scan of what those shapes are representing will help you. Next is interpreting what the question is actually asking. Because if you don't know what the question is asking and you just sit there for 30, 40, 50 seconds interpreting the legend, you're wasting time. And that's not what you want to do. So it's a balance between looking at the legend, knowing what the question is asking, so that when it comes to actually solving the question, you can get to it straight away. Number 2 is overlaps. So for direct questions, this isn't relevant. But for questions like which of the following is true, then what I recommend is just do a bird's eye scan to see the distribution of numbers inside the categories themselves. So what this means is like, have a look at here, spend 5 seconds just having a look at where those big numbers are. 1 here, 1 here, 1 here, 1 here, some here as well. Just so that when it comes to answering the question, you've got a better idea of what the distribution of the number looks like. So the reason why that might help is because when you actually go and solve the question, now you have a better idea of where those numbers are going to be. Again, just 5 seconds, tops, nothing more. Otherwise, you're wasting time. This is just a bird's eye scan. And 3, now select. So for which of the following is true questions, there is no need to go from option A to D. What I want you to do is select the option that seems most feasible. Start with the statement that is most likely to be true or the most simple to prove. For example, X has more apples than Y is much more likely to be true than A has 7 less bananas than B. The reason being is because for this to be true, X can have 1 more apple, it can have 2 more apples, it can have 143 more apples. It doesn't matter as long as it has more apples than Y. Now, for this to be true, it can't be 5, it can't be 6, it has to be 7 exactly less bananas than B. So that's less likely to be true. Now, the last step is the total check. You got to use your calculator or the numpad in a lot of these questions to quickly add the numbers if needed. Now, if you haven't already watched my video on the calculator, then please do, because that goes through all the things you need to do to get razor quick with the calculator. And that's important because for a lot of these categories questions, your speed matters, especially with the calculator. So with that in mind, let's go through some questions, right? Starting off with this one. What I want you to do is pause the video here and apply the lost method to answer this as quickly as you can. All right, fantastic. Let's go through this question together now. So first things first, legend. Let's have a look. So these are different sports and you've got like big basketball here, swimming here, tennis. That's the big one there. Okay, lovely. And then let's have a read of the question. How many members participate in basketball, tennis, and football, but not badminton and swimming? So we want tennis, we want basketball, and we want football, which is the heart here. Lovely. So I'm going to look for an intersection between them all. Overlaps, just a quick scan of where everything is. I'm basically now just solving the question. We're up to S now, except we don't have to pick any of the options because this is not a which of the following is true. So we just skip straight to T, which is a total check. So the answer is 75 because we can see that's the only intersection between these shapes. So D is our answer. But if there was maybe multiple numbers here in that little intersection to add up, that is where you then pull up the calculator and start calculating ASAP. So the answer here is D. And you can see this is probably as simple as some of these questions get. Now, let's move on to one more example of the categories with this question. So feel free to pause the video now and apply the lost method. All right, let's jump into this one now. So L, legend, we've got shops and then we've got flavors. That's what it looks like here. So we've got shop here, and then a different bunch of flavors in the middle. Fantastic. So what's it asking? Which of the following statements is true? So it's going to be one of those S questions where we actually have to think about which one's going to be the most feasible. Overlap wise, it looks pretty even to me in terms of distribution of numbers, so I'm just going to move on. We've got S, which is to select the most feasible. Shop A has exactly 8 more cookies, not a fan. Both shops have exactly the same, not a fan. Shop A has exactly 15 fewer, not a fan. So shop B has more cookies with cinnamon flavors than shop A. I like the look of that one. Doesn't mean it's going to be the answer. It means that I'm just going to go through it first so that if it is the answer, I haven't wasted a bunch of time. So let's evaluate that. This is where we're up to step T, which is basically to add up the totals if we need to. So where's cinnamon? First of all, we know that that is here. Shop B is our pentagon. We've got 24, 8, 25. And shop A is our circle. We've got 11 and 8. Now, you don't need the calculator to solve this because mental maths, just quickly, like the 8 and 8 cancel out. These numbers are clearly bigger than 11. You know C is going to be your answer. But if this was a question where it was maybe a bit tighter between the two, then this is where you would pull up that calculator and go as fast as you can to try and calculate what that answer might be. So C is our answer here, and hopefully you can see how applying that lost method can save us a bit of time in these questions. Now, if you're finding this helpful so far, then the lost method is just one of the many methods and frameworks that I have for the UCAT. And if you want to find all of my frameworks in one place, then just click the first link in the description below. Otherwise, let's move on to the next question type. Which one fits? So these questions look like this, where they'll give you a stem and then they'll ask you which one of the following diagrams represents it best. So for the legend, if it's provided, then interpret the legend. For some questions, it'll give you one. For others, it won't. Let me just skip ahead. I'll show you. So this one, it doesn't. For this one, it does, where it says you've got the rock genre with the oval and then the jazz by the square and so on and so forth. So for some questions, it will give it to you, and that's where you want to interpret it, but some won't. So just keep that in mind. For the overlaps, you want to comprehend the keywords being used here and actually just understand what they mean and visualize them. For example, none of the basketballers played the other sports means there must be a circle that is not overlapping with any other circle because they can't be. These basketballers can't have played whatever other sport this is and whatever other sport this is. Something like everyone liked at least one flavor means that there's no one that didn't like a flavor, which means there's a 0 on the outside because everyone probably liked one of these flavors. And then this is where you got to be aware of the word only. We've gone through that, so I won't harp on about it, but be aware of the word only. Number 3 is to select. So this is where you reject options that obviously violate the only or none or at least one principles. You can usually eliminate 1 or 2 options this way. Now, I found from experience that the correct answer is usually 1 of 2 very similar diagrams. So you want to focus there. This is like multiple choice theory 101. But yeah, it's true here as well. It's usually 1 of 2 similar diagrams. Then, once you select the option, you want to check if the circle overlaps and match the relationships in the stem, basically answering the question. Now, as a last resort, you can sketch your own Venn diagram and match, but I tend to see that that's probably not the fastest way to solve this particular question type. So I tend not to do that. And lastly, as a total check, There are some rare cases where the total number inside the Venn diagram won't match what the stem says. This is what I was mentioning earlier in the overview, where if there's 46 people and then it all adds up to 43, then it's just not going to be the answer. Now, you're not going to sit there and add up all the numbers inside the Venn diagrams as soon as you see one of these questions. That would be a waste of your time. The way you recognize this total check thing is there a Venn diagram that just has a different number to the rest of them? And if so, that's likely to be not one of the answers. Because remember, the answer is likely to be one of two or sometimes three similar looking options. So with that in mind, let's apply the loss principle to this. Pause the video now and have a go. All right, let's run through this together now. So legend, there isn't one. So we can move on. The overlaps, this is where we start trying to make sense of what we have here. So 8 patrons read fiction, sure. That's not my best statement. Think of it like logical puzzles. Like you want to find the concrete piece of information where you can really visualize something. 12 patrons, of which 4 also read fiction, read non-fiction. Again, just too many words for me to comprehend at the moment. I'll get back to it. 9 patrons read poetry. None of these read either fiction or non-fiction. Okay, so now I'm looking for a poetry circle with 9 on its own because they didn't read fiction or non-fiction. From that alone, we can actually pick A as our answer. And A is our answer, right? But I'm just going to go through the rest of the question just so we're happy. 6 patrons did not read any books. They only used the computers. So we've got 6 on the outside, 6 on the outside, 6 on the outside. So A, C, and D are reasonable answers. You see the 9 on the outside here? That's what makes B completely unreasonable. And that's how you can just completely get rid of one of these by looking at the select principle. Cool. So then if we fill in the rest of the gaps, does it make sense? That's the question. So we've got 8 patrons read fiction and then 12 patrons, of which 4 read fiction. So 12 is going to be the total of one of them. And then if you can imagine this to be the overlap, of which 4 read fiction. So it's going to look something like that. So it's going to look like something like this, because you want this total to add up to 12. Which one looks like that? We've got A. A looks like that. So A is our best answer in this case. Obviously, look, the moment you realize that the 9 and 6 and this, and then you know that A is going to be the answer, you just select it and move on. You don't need to necessarily verify everything. But it's good to know just from a best practice point of view in case you come across harder questions. All right, let's keep on moving. Let's go to our next question. So pause the video here and have a go at this one. Fantastic. Okay, let's go through this one together. So everyone listened to at least one genre. So we know that there's going to be 0 on the outside because they all listen to one. That doesn't really help us because all of them have that. The number of people who listen to rock genre only was half the number of people who listen to both jazz genre and classic genre. Okay, again, that's probably a really key piece of information, but it's also really wordy. And I don't want to mentally tax myself yet until I read everything. Because something like 5 people listen to all 3 genres is a piece of gold. Because you know that in the middle, you're expecting 5. So then when you see a 4, what's that doing there, man? Just get rid of it. So now what we can do is start labeling. So legend-wise, we've got the oval with rock. And then we've got the people who listen to jazz as a square. And then we've got the classical genre with the pentagon. Lovely. So now that we've labeled, now that we know what it looks like, we can start to make sense of something like this. The number of people who listened to the rock genre only, so you're basically looking at this number, was half the number of people who listened to the intersection of jazz and classical. So the intersection of jazz and classical is this. So is this number half of this? Yes, it is. So by chance, I've decided to annotate answer B, which is our correct answer here. But you can see that with the other ones, that just doesn't follow through. So that's why our answer in this case is B. So hopefully, again, you're seeing how the lost method can be applied to this specific type of Venn diagram. All right, let's keep moving on. We've got the next question type, which is DIY. And they look something like this, where they give you actually no numbers, but they give you just words. And your job here is to pick the Venn diagram that best represents the information that you see in front of you. Again, no numbers. So here's how I go through these questions. Number 1, with your legend, you got to make your own essentially, because you decide what each circle represents now. So the way I recommend this is to keep track using letters next to circles. The same way you would make Venn diagrams for syllogisms, for example, that's what you do here. For your overlaps, you need to turn your sentences into visual relations. For example, if it says Group A only played violin, then you know that there's a circle with no overlaps with others. Again, similar to what we just did with the which one fits. And if there's the people who played cello also played the double bass, then you know there's a circle completely inside the other. The people who played cello also played the double bass. And then the next step is sketch. This is where you draw diagrams. So you notice how in the which one fits, I said probably not. You don't want to draw them because you'd rather just see which one fits the numbers the best. For this one, I found you can't really do that. So you have to draw them out and then see which of the options matches what you've just drawn. So draw your diagrams, label them clearly using letters. Use your relations that you've just thought about with the overlaps to add or remove overlaps, and then choose the answer option that best matches your sketch. Then, with the total check, nothing exciting here. If the answer contradicts the STEM wording, then you reject that option. So let's get into it. This is one of those questions. Pause the video now and apply the lost method. All right, let's go through this question together now. So 12 participants attended the art workshop day. Okay, so people who attended art workshop, but they did not join every session. Cool. 4 participants attended the pottery sessions. They took no further part in the day. So the people who took pottery took no further part in the day. So I know pottery is going to be somewhere on its own. Pottery here. 3 participants attended the sketching and watercolor. So that's literally telling you there's an intersection between those two. So sketching and watercolor, but not the pottery or sculpture sessions. So I'm going to put SK for sketching because I know I'm going to use SC for sculpture later. The 5 participants who attended sculpture also attended sketching and watercolor. So I know there's an intersection between sketching, watercolor, and sculpture. And the only way I can do that is if there's a 3-way Venn diagram here. So, which of the following represents the group of 12 participants? Is there a option here which represents that? And we can see the only one with a 3-way intersection here, pottery on its own, looks like option B in this case. So, B is our answer. Alrighty, and let's move on now to our final question type, which is worded questions. These ones do come up a lot, so we need to know how to go through them. They look like this, where they don't give you anything but words and numbers for you to then solve the Venn diagram. So here's what we do. For the legend, when sketching, you define the circles for yourself using letters, exactly like we just did for the DIY question types. For the overlaps, beware of the word only. Again, we've gone through this, so I won't harp on about it. Now, for the sketch side of things, it's actually not always necessary, but I do think it helps with the foundation. So if you're getting better, if you're learning Venn diagrams and you've got a bit of time before your exam, then do them because it helps you figure out what's going on from a visual lens. That's how you learn. They are sometimes needed, so you can't just not draw them. You do need them at times. But essentially what you do for sketch is you just draw it. You draw the Venn diagram and you label it clearly. Remember to consider a none of these regions as well. Then for the total check, this is where once you've got the diagram sketched, just find the totals by adding the relevant numbers. Now, I did say you don't have to sketch it every time. And what I meant by that is there is a mathematical method of figuring out the total number should you need to. And the way you do this is as follows. So if we had, if we had red, green, blue, like this, actually I'm just going to say ABC because that's what the example says, ABC, and you want to find the total number of numbers in this Venn diagram, then here's the formula. You add up the number of A, not just A, not only A, but all of A. So if I remember, it was 31 from the previous example, and I forgot, I think this was 42. From memory, this was 37. Maybe I got that wrong. Who knows? Okay. But let's just say that those were the totals. What you would do is you would add them up. Now, the reason why, if you add them up, you're going to get larger than the total amount there actually is is because by adding up A and then B and then C, what you've done is you've double counted some of them, and in some case, like actually just triple counted. Sorry, this should say triple. Okay, what do I mean by that? So if there was the number 9 in this case, then by adding the 31 and then the 42, this number 9 has been added twice. So what we need to do is account for that. So from whatever total this is, we subtract that intersection of 9. Likewise here. We subtract that intersection of 5 because it's been double counted. And again, I forgot what this number was from the exam. I think it was 8. Okay. So we subtract that 8. So this one would be whatever that total number was, minus 9, minus 5, minus 8. Now, this number here, the 4 that was in the middle, we subtract that twice. Why? Because when you add up A, when you add up B, when you add up C, you've added this number 4 3 times. And we only want to count it once. So what do? We cut off the 2 that we've triple counted it as. So that ends up being minus 2 times 4, or minus 4 twice. And you'll find if you apply this formula, you're going to get the total number of whatever it is in the Venn diagram. So look, if you're not comfortable with this, just go back, scroll back through the video to the Marsha and the dogs example and go for it and apply it yourself. There will be a question that'll come up, but we can apply it there. So do whatever you like, but we're going to go through some questions now. So starting off with this one. Maybe you can use it, maybe you can't. It's up to you to decide. So feel free to pause the video now and have a go at this question. All right, let's go through this question together now. So actually, this is one of those examples where we couldn't use the mathematical method. Or maybe we can, and I just don't know of it. But I'm just going to show you the visual method instead. So we've got 32 recipes in total. The recipe uses 16 recipes only chocolate. So we're going to have chocolate here and 16. And we've got vanilla as well, and then we've got cinnamon. So just setting up the Venn diagram. Lovely. One recipe used vanilla and chocolate only. We've got 12 recipes used vanilla and cinnamon. So that refers to this intersection here, including this. So I'm not going to put the number 12 anywhere because I don't know what any of those numbers are yet. So again, beware of the word only. 6 recipes used only chocolate. So I can put that there. 7 recipes used all 3 types. And 3 recipes used only vanilla. So from this, how many recipes used cinnamon only? So what we need to do here is fill in the rest of the Venn diagram and then work our way backwards to finding only cinnamon. So we've got 16 here, and 16 minus 6 is 10, minus 1 is 9, minus 7 is 2. So we've got 2 here. And then we can find the vanilla, because we know that this intersection between cinnamon and vanilla is 12 in total. We've got 7 in the middle. 12 minus 7 is 5. And then we can subtract all the numbers from the Venn diagram from 32, because we know that's the total, to find our answer here of 8. So our answer here is 8. Hopefully this shows you how you can use Venn diagrams and sketch them out to actually answer questions like this one. All right, let's move on to our next example. So feel free to pause the video here and give it a shot. All right, let's run through this question together now. So first of all, what are we going to do? We're going to do a legend. Again, nothing to do from a legend point of view other than make our Venn diagram and label them. So we've got drama, debating, and sports. So I'm going to do drama, debating, and sports like so. Now, from an overlaps point of view, it looks like just understanding what's in front of us. So we've got 60 joined the drama club. So we're going to put a 60 on the outside, 43 the debating, and then 81 the sports club. 20 joined only the sports club and the debating club. So we're going to put the number 20 here. 12 joined the debating and drama club only. So we're going to put a 12 here, and 9 joined the sports and drama club only. So here. And then 7 joined all 3. So we put a 7 there. Now with the totals on the outside like so, we can find whatever this is, X, Y, Z. And then we have the number of people that attended all of these clubs. Now what's the question, right? How many students joined none of these 3? So we've got 150 students total. We just subtract whatever this number ends up being. But, guys, is there a faster way to get to this answer without even drawing a Venn diagram out? And this is where that method, that maths method, comes in really handy, because you can use all the numbers in front of you and then just get to the answer. So if we just added up the drama, the debating, and the sports, 60 plus 43 plus 81, then we're going to double count and triple count some numbers. So that's going to be more than the total in the Venn diagram we're looking for. So what do? We subtract the ones that we've double counted. So we've double counted one count of 20, one count of 12, and one count of 9. So minus 20, minus 12, minus 9. And then we've triple counted this 7. So we subtract 7, and then we subtract 7 again. And then so that gives us the answer of 129. So what is this representing? This is representing everything in the Venn diagram. This is what the total amasses to, 129. So let's answer the question. How many students joined none of these three? Well, it would be 150 minus 129, giving us our answer of 21, otherwise B. So, wow. What we've just done there is saved ourselves the hassle, the time of having to draw out this entire Venn diagram and fill in all of those numbers, because we can use the numbers right in front of us to mathematically find out what the total of this Venn diagram is going to be, so that we can answer this question without needing to do all of that work. So that's why I'm a big fan of this mathematical method. It saves you a whole bunch of time. All right, so this was just a handful of questions we've gone through, and the way you get better at these Venn diagram questions is doing more and more practice questions. So if you don't already have a question platform to do these questions on, then you can use the code Farhan for 10% off MedEntry. Otherwise, let's go through some traps that students tend to fall into. Number one is misinterpreting the words only, both, or none, especially the word only. Number two is ignoring the legend. I think this is a massive time sink, because you end up needing to go through it anyways. And number three is evaluating options from A to D when you really don't have to. Just pick the most feasible one and then go through that first. So here's your do's and don'ts. Do pay close attention to keywords, especially the word only. Do orient yourself with the legend first if possible, if they give it to you. And do select smart, sketch, clear. Don't go top to bottom through every option. Don't skip the legend interpretation, and don't try to hold it all in your head. Draw it out, because that's how you answer a lot of these questions. So here's your next step. For the next 10 Venn diagram questions you do, I want you to apply the LOST method according to the question types. So LOST, just as a summary, is legend, overlaps, sketch or select, and then a total check. And apply it to all of the question types that come your way.